Close your eyes. Let the weight of the world drift away, like a lone speck of dust floating in the vast emptiness of space. Imagine yourself suspended in the cosmos, where time slows, where silence stretches infinitely, and where the boundaries of reality begin to blur. The stars shimmer in the distance, ancient sentinels whispering secrets of a universe far older than we can comprehend. The planets move in perfect rhythm, yet somewhere in the fabric of existence, contradictions lurk. Mysteries so profound they defy logic itself. Tonight, we embark on a journey through the strangest, most haunting paradoxes of the universe. These are questions that challenge the very nature of reality, riddles that scientists and philosophers have pondered for centuries. Why is the night sky dark if the universe is filled with stars? Why haven't we met intelligent life if the cosmos is so vast? Can information be erased forever in the abyss of a black hole? And could time itself be an illusion, slipping through our fingers like grains of cosmic dust? With each passing moment, let your mind sink deeper into the unknown. There is no rush here, no urgency, only the quiet hum of the universe, stretching endlessly beyond the edges of perception. As we explore these paradoxes, let your thoughts wander, let curiosity guide you, and let the vastness of space cradle you into a peaceful, dreamlike state. Breathe in, breathe out. The journey begins. The Fermi Paradox. Where are all the aliens? Out there beyond the soft glow of our own planet, beyond the moon's quiet embrace and the endless swirl of galaxies, an unsettling question lingers in the silence of space. Where is everyone? The universe is ancient, billions upon billions of years older than humanity itself. And in that vast stretch of time, among the trillions of stars, the countless planets, and the infinite possibilities, logic tells us we should not be alone. The night sky should be teeming with life. Signals should be reaching us from civilizations far beyond our own. And yet, there is nothing. Only silence. A great cosmic stillness that stretches across the fabric of existence, unbroken and absolute. The question was first asked, at least in its modern form, by physicist Enrico Fermi in the 1950s. If intelligent life is not a rarity, he reasoned, then why has no evidence of extraterrestrial civilizations ever been found? Shouldn't the skies be filled with the echoes of alien voices, the flickering lights of distant space stations, the remnants of civilizations far older and wiser than our own? The very vastness of space makes it seem inevitable that we would have encountered something by now. And yet, in the depths of the cosmic ocean, we appear to be alone, adrift on a tiny island of consciousness with no sign of neighbors. There is something almost eerie about the silence of the stars. Imagine standing on a beach at night, staring across an endless sea. If you knew, beyond a doubt, that islands filled with people existed just beyond the horizon, wouldn't you expect to see distant fires flickering? Wouldn't you hear faintly the echoes of voices carried by the wind? But instead, there is only the lapping of waves, the endless black void stretching forward, untouched, undisturbed. The universe feels much the same way, a place where life should be abundant, where voices should be calling out to us from every direction. And yet, there is nothing but a great and unsettling quiet. Could it be that we are among the very first? That life, in all its infinite potential, is only just beginning to take root across the cosmos? If that were true, then we would be like the first embers of a fire, just beginning to glow in the darkness, waiting for others to ignite. But this answer, though simple, feels deeply unsatisfying. After all, stars and planets have existed for billions of years before Earth was even formed. If life is not unique to our world, then surely some civilization, somewhere, must have reached the stars long before us. They would have spread across the galaxy, left their marks, made their presence known. So why is there no trace? Perhaps the answer is darker than we would like to admit. Perhaps civilizations do arise, but something, some unseen force, prevents them from expanding too far. Some call this the Great Filter, an invisible barrier that stands in the way of life reaching its full potential. It could be an inherent instability in intelligent species, a tendency to self-destruct before they ever reach the stars. Or it could be something external, something waiting in the darkness, something that ensures no civilization grows too powerful, too ambitious, a predator lurking in the void, unseen but ever watchful. Or maybe we are being watched. Maybe the silence is not an absence, but a choice. Some theorists suggest that the universe is like a great zoo, where Earth is part of a vast and carefully controlled experiment. Advanced civilizations existing in the shadows could be observing us, waiting for the right moment to reveal themselves, or perhaps ensuring we never grow aware of them. If we were to send out a signal, a message into the void, would something answer? Or would we hear only the whisper of the cosmic wind, gently reminding us that we are alone? But what if we are not alone? What if we are simply looking in the wrong way? It is possible that alien life exists in forms so different from us that we wouldn't even recognize it if we saw it. We search for signals in radio waves, for planets like Earth, for signs of civilizations that mirror our own. But what if life flourishes in ways beyond our comprehension? What if intelligence does not communicate in ways we understand, does not build structures we can detect, does not think in ways we can imagine? Perhaps the aliens are already here, not in flying saucers or distant galaxies, but in the very fabric of the universe itself. There is another possibility, one that unsettles the mind in the quiet hours of the night. What if we are truly alone? Not because other life hasn't had the chance to exist, but because life itself is a cosmic accident, a phenomenon so rare that it may have happened only once, here on Earth. This idea is both exhilarating and terrifying. If we are the only conscious beings in the entire universe, then every thought, every dream, every moment of human existence is unique on a scale beyond comprehension. But it would also mean that the great silence stretching across the cosmos is not a mystery to be solved, but simply the sound of an empty and indifferent universe. Perhaps the answer to the Fermi Paradox lies in the future, waiting for us beyond the horizon of time. Maybe one day, humanity will break the silence, send our voices out into the great unknown, and finally receive an answer. Or maybe, just maybe, some distant civilization is staring up at their own night sky, asking the same questions, wondering if someone somewhere is looking back at them. Until then, the stars remain quiet, the darkness unbroken, and the mystery unsolved. The Bootstrap Paradox, a loop without a beginning. Time is supposed to flow like a river, from the past to the present, always moving forward, never doubling back on itself. But what if time isn't a straight line? What if it's a circle? A never-ending loop where cause and effect chase each other endlessly, where something can exist without ever having been created. This is the strange and haunting reality of the Bootstrap Paradox, a puzzle so perplexing that it seems to defy the very fabric of logic. Imagine this. You wake up one morning to find an old, dusty book on your desk, filled with secrets about the universe, equations, discoveries, and ideas that seem beyond human understanding. You read it, you study it, and over the years you come to understand its mysteries. You rewrite the book in your own words, publishing it for the world to see. Centuries later, someone finds your version, copies it, and the cycle repeats. But here's the problem. If the book was given to you and you simply rewrote it, then who wrote it first? This is the essence of the Bootstrap Paradox. An object, a piece of knowledge, or even a person trapped in a time loop, existing without ever having been created. It is named after the idea of pulling yourself up by your own bootstraps, a metaphor for something that sustains itself, without any clear origin. Like a snake eating its own tail, or a dream that never had a beginning, this paradox challenges everything we believe about cause and effect. One of the most famous examples is the paradox of Beethoven's music. Imagine a man who travels back in time with sheet music of Beethoven's greatest symphonies. In the past, he meets young Beethoven and gives him the compositions, claiming they are his own. Beethoven copies them, claiming them as his own work. Centuries later, the time traveler finds Beethoven's music, takes it back in time, and gives it to him once again. But if Beethoven never actually wrote the music, if he simply copied what was given to him, where did the music come from? The paradox plays with the very nature of time itself. If something is passed from the future to the past, and then from the past to the future, without an original starting point, does it truly exist, or is it simply an illusion, a glitch in the fabric of time, a loop that can never be broken? It suggests that some things may have no true origin, they exist simply because they exist. But the deeper you think about it, the stranger it gets. What if your entire life is part of a bootstrap paradox? What if the thoughts you have, the ideas you create, the dreams you chase, what if none of them truly belong to you? What if they were planted by something beyond time, given to you by the echoes of a future that has already happened? And if that's true, then who is really in control? In physics, some theories suggest that time doesn't truly flow, that past, present, and future all exist at once, like frames in a film reel. We only experience them in sequence because our minds can only process reality in one direction. But if that's true, then the Bootstrap Paradox could be more than just a puzzle. It could be a fundamental truth about how time works. Things may not need a beginning because beginnings themselves might be illusions. The idea of a loop without an origin is unsettling because it breaks our understanding of how the world works. We're used to the idea that every effect has a cause, that things must come from somewhere. But the Bootstrap Paradox suggests a reality where cause and effect merge into one, where time doesn't just move forward, but folds back on itself like a Mobius strip, endlessly looping. Some physicists believe that our universe itself might be trapped in a cosmic bootstrap paradox. What if the laws of physics, the rules that govern reality, were not discovered, but passed through time in an endless loop? What if the reason the universe exists is because it has always existed, without a creator, without an origin, without a first moment? The more you think about it, the more dreamlike it becomes. Imagine walking through a door, only to find yourself stepping back into the same room from the other side. Imagine writing a letter to your future self, and one day receiving it in the mail, only to realize that the letter was never written, only passed between past and future forever. What happens when time has no beginning, only a cycle that repeats endlessly? And if this paradox is real, if objects, ideas, and even people can exist without a true origin, then what does that say about you? Are your thoughts your own, or have they always existed in some form, passed down through time like echoes of a song with no composer? Are your choices truly free, or are you simply following a path that has already been written? Perhaps the universe itself is caught in an eternal loop, where time is not a river, but a wheel that turns endlessly. Perhaps reality is not something that moves forward, but something that sustains itself, feeding back into its own existence. Perhaps you are part of a paradox, a being without an origin, a moment without a beginning, a dream that was never first dreamed. But as these thoughts settle in, as your mind drifts further into the quiet stillness of the night, the paradox begins to feel less like a puzzle and more like a lullaby. The universe, with all its mysteries and contradictions, hums softly like a song that has always been playing. And as you close your eyes, as your breath slows, you realize that maybe, just maybe, you have been here before. Maybe this moment, this feeling, this drifting into sleep has always happened. The twin paradox, a journey through time itself. Time is supposed to be constant, a steady flow that carries us all forward at the same unchanging pace. But what if time is not what it seems? What if it bends, slows, and stretches depending on how you move through the universe? This is the eerie mystery of the twin paradox, a thought experiment that warps our very understanding of time and reality. Imagine two twins, born at the same moment, sharing the same past, the same childhood, the same memories. They are identical in every way. But one day, one twin embarks on an incredible journey. He boards a spaceship and sets off at near the speed of light, traveling across the cosmos, witnessing the silent beauty of the stars. Meanwhile, the other twin stays on Earth, watching the years pass, feeling time move as it always does. But here's the paradox. When the traveling twin finally returns home, something unimaginable has happened. While only a few years have passed for him aboard his ship, decades have passed for his twin on Earth. The twin who stayed behind is now an old man, while the one who traveled through space remains young, as if time had barely touched him. Two people, born at the same moment, now exist in entirely different eras. This paradox isn't just a thought experiment, it's a real consequence of Einstein's theory of relativity. The faster you move, the slower time flows for you. At near light speeds, time almost comes to a stop. A traveler moving fast enough could leave Earth for a short trip, only to return centuries later, finding their homeworld unrecognizable, filled with people who have long forgotten them. They have become a relic of the past, while barely aging themselves. But the strangeness of the twin paradox goes deeper than just time slowing down. If one twin is moving and the other is stationary, doesn't that mean each twin could claim that the other is the one truly moving? In a universe where everything is relative, how can we decide whose time is really slower? The paradox reveals a haunting truth about time. It is not a universal experience, but something that shifts and bends based on perspective. Now imagine what this means for space travel. If humanity ever discovers a way to travel near the speed of light, astronauts could venture to distant stars and return home to find Earth centuries or even millennia in the future. A traveler might set out on a mission with loved ones still alive, only to return to a world where they are nothing more than distant history. The people they knew, the voices they cherished, the world they left behind, all gone in the blink of an eye. The twin paradox turns time itself into a mysterious, elastic force. Something that doesn't just move forward, but twists and warps based on where you are and how fast you go. It suggests that the past and the future are not fixed points, but shifting, changing landscapes, always just out of reach. What does it mean to live in a world where time is not absolute, where the ticking of a clock is not a universal truth, but a matter of perspective? Some physicists believe that this paradox hints at something even deeper, that time travel may not be impossible after all. If moving fast enough slows down time, then what happens if you go faster than light? Could you, in theory, move backward in time? Could you step out of a spaceship and find yourself in the past, reliving moments that have already happened, seeing the world before it changed? And if so, could you change it? The paradox also raises an unsettling question. If time is relative, then what is the true present? If two people experience time at different speeds, then whose present moment is the real one? Is there even such a thing as a universal now, or is the present just another illusion, shifting from person to person, perspective to perspective? Perhaps the scariest part of the twin paradox is what it tells us about our own lives. Every second, we are moving, shifting, traveling through the fabric of space. Could it be that, in ways we don't yet understand, our own time is being stretched and twisted? Could it be that two people sitting side by side are, without realizing it, experiencing different flows of time? And then there is the final, eerie thought. What if you, right now, are living in a distorted version of time without even knowing it? What if somewhere, in some distant place, a version of you exists that has moved differently through the universe? What if, while you sleep, another version of yourself has already lived an entire lifetime, grown old, and faded into the past? Time is not what it seems. The twin paradox whispers to us that the world we see, the reality we believe in, is not fixed, but fluid, bending and shifting in ways we are only just beginning to understand. It suggests that our journey through time is not a straight path, but a winding road where the same moment might be experienced at different speeds, in different ways, by different people. So as you close your eyes, as sleep begins to pull you away, imagine yourself drifting through the cosmos, floating in a place where time moves differently, where the seconds stretch and shrink like waves in the ocean. Imagine yourself as a traveler, moving through the universe at a pace that only you can feel. And as you slip into dreams, let the paradox surround you, reminding you that time is a mystery, one that we may never truly solve. The Fermi Paradox. Where is everyone? The night sky is a canvas of infinite stars, each a tiny beacon whispering secrets from the distant past. When you look up at the vastness of the cosmos, a thought inevitably creeps in. Are we alone? The sheer number of galaxies, stars, and planets suggests that life should be everywhere. There should be civilizations out there, reaching across the darkness, calling out to us. And yet, when we listen, we hear only silence. This is the mystery of the Fermi Paradox. It is a paradox that gnaws at the edges of our understanding. If intelligent life is common in the universe, then why have we found no evidence of it? Why, after decades of scanning the skies, have we received no signals, no messages, no signs that we are not alone? The universe is billions of years old, time enough for countless civilizations to rise, expand, and make themselves known. And yet, they remain hidden. Some believe that the answer lies in the great silence, the idea that civilizations exist but choose to stay quiet. Perhaps the universe is like a vast, dark forest where every species hides in fear, knowing that something lurks in the shadows, something powerful, something terrifying. If an advanced civilization were to reveal its presence, it might attract the attention of a force beyond comprehension, something that does not respond with curiosity, but with destruction. Others suggest that civilizations may rise and fall like waves in the ocean. Perhaps life is fragile, and intelligence is a rare, fleeting moment before extinction. Civilizations may emerge, grow, send their first signals into space, only to vanish before they ever meet another. If every species follows the same path of self-destruction, then the silence is not a mystery. It is a warning. But what if the answer is something stranger? What if we are the first? The first intelligence to reach this stage, the first to look out and wonder, the first to send out signals in search of others? The thought is exhilarating and terrifying. It would mean that we are alone, that the responsibility of understanding the universe, of shaping the future, falls entirely on us. It would mean that if we fail, there may never be another. Then, there is the possibility that they are already here, hidden in the folds of reality, watching us, studying us, waiting for the right moment to make themselves known. Perhaps we are like fish in a pond, unaware of the vast world above us, oblivious to the eyes that gaze down from beyond the stars. Could it be that we are being observed, our every move monitored, without ever realizing it? Some theories suggest that the answer lies not in the stars, but in time itself. If civilizations exist, they may be so advanced that they have no need to travel between planets. They may have transcended physical existence altogether, existing in digital or post-biological forms, no longer bound by the need for exploration. To beings like this, we might be nothing more than an echo from a primitive past. And then, there's the most unsettling thought of all. What if we are alone? What if the universe is vast and empty, and we are a rare accident, a spark of consciousness in an otherwise silent cosmos? The loneliness of this idea is almost unbearable, but at the same time it makes our existence more precious. If we are the only ones, then every life, every thought, every dream, they all matter more than we ever imagined. The Fermi Paradox is more than a scientific puzzle. It is an existential riddle, one that challenges our deepest beliefs about life and meaning. If we are not alone, then where is everyone? And if we are alone, then what does that mean for us? Are we meant to be the pioneers of the cosmos, or are we simply shouting into an infinite void, hoping for an answer that may never come? As you drift into sleep, imagine the endless stars above, stretching far beyond sight, each one a potential home for something, someone, waiting in the silence. Feel the weight of the unknown pressing gently around you, the quiet hum of the cosmos wrapping around your thoughts like a soft cosmic lullaby. And in that silence, in that mystery, let yourself drift into the depths of the unknown, where dreams and reality blend into one. The white hole paradox, the other side of a black hole. The universe is filled with mysteries, each more unsettling and awe-inspiring than the last. But among the strangest is the paradox of white holes, hypothetical entities that seem to defy the very nature of existence. If black holes are cosmic devourers, consuming everything that dares to cross their event horizon, then white holes are their enigmatic opposites, places that spew matter and energy outward while never allowing anything in. Imagine a cosmic fountain that never runs dry, a gateway from which the past is constantly spilling forward into the future, a door that can never be opened from the other side. If a black hole is a prison from which nothing escapes, not light, not time, not even the concept of existence itself, then a white hole is the opposite, an eternal outpouring of all that has ever been consumed. Imagine if the universe held hidden pockets where the past is regurgitated, where every lost particle, every swallowed planet, every forgotten star finds itself thrust back into reality, ejected into the cold, endless void like echoes of a past we thought was gone. Some physicists theorize that every black hole is connected to a white hole on the other side, that what is swallowed in one place does not vanish, but is instead reborn elsewhere, ejected into a different time, a different place, a different universe entirely. If this is true, then the cosmos is threaded together by hidden corridors, tunnels through space-time, unseen highways where matter vanishes in one realm only to emerge in another, as if the universe itself is constantly reshuffling its contents in ways we may never understand. But if white holes exist, why haven't we seen them? A black hole announces itself boldly, warping light, bending space, dragging entire galaxies into its gravitational abyss. A white hole, however, is something different, something untouchable, unreachable, something that may exist only at the very edges of time itself. The laws of physics suggest that a white hole should be an object of perfect isolation, eternally sealed off from the rest of existence, forever ejecting but never absorbing, like a river that can never be traced back to its source. Some believe that white holes are the echoes of dying black holes, that when a black hole has reached the end of its cosmic life, it does not simply fade into nothingness. Instead, it may transform, releasing all it has ever consumed in a final, brilliant burst of light. A farewell to the universe, a last confession before slipping into eternity. If this is true, then black holes are not merely cosmic traps. They are cosmic cycles, engines of destruction that one day become engines of creation. Others whisper an even stranger possibility, that the Big Bang itself may have been the result of a white hole. That our entire universe is simply the outpouring of some great cosmic entity in another reality. A place where a dying black hole collapsed so completely that it created a new realm entirely, spilling its contents into an empty void, igniting the birth of time itself. If this is true, then we are living inside the remnants of something greater, something older than we can comprehend, a universe that was never truly born, but rather was expelled into existence from a place we will never know. But if black holes turn into white holes, what happens to everything that was inside? Does it emerge intact, unchanged? Or does it become something else entirely, reassembled, rewritten, reborn? If time behaves differently within a black hole, then perhaps what falls in is not simply ejected, it is transformed. Perhaps every black hole is a crucible where the laws of reality themselves are melted down, rewritten, and sent forward into the cosmos in a form we cannot yet understand. There is another chilling idea. What if white holes exist, but we simply cannot recognize them? Some scientists believe that the mysterious quasars, those celestial beacons of light that shine from the furthest reaches of the universe, may not be ordinary stars or galaxies at all. Instead, they could be white holes, portals through which ancient matter is spilling back into existence, lighting up the void with the remnants of a past long forgotten. But there is something haunting about the nature of white holes, something unsettling. If they are real, then they are the ultimate paradox, places where time runs backward, where the past is constantly returning, where what was lost is never truly gone. And if they are real, then they suggest something even stranger, that reality itself is not a straight line, but a loop, a cycle of consumption and rebirth, a universe endlessly devouring and regurgitating itself in ways we may never comprehend. Imagine standing before a white hole. Unlike a black hole, which drags you forward with inescapable force, a white hole would do the opposite. It would push you away with unimaginable power. No matter how much you tried to approach, you would be repelled, flung backward, rejected by the very fabric of space. It would be a place forever out of reach, a secret forever kept, a door forever closed. And yet, perhaps white holes are not meant to be seen. Perhaps they are not cosmic objects at all, but the hidden architecture of the universe itself, the unseen machinery that allows existence to loop back on itself, the silent mechanism that ensures time does not simply march forward, but bends, twists, and folds in on itself like a cosmic ribbon. If white holes exist, then they force us to reconsider everything we know about time, space, and reality itself. They tell us that nothing is truly lost, that destruction is never final, that every black hole is a promise rather than an ending. If they exist, then the past is not truly gone. It is merely waiting to be reborn, waiting to spill forward once more into the ever-expanding mystery of the cosmos. And so, as you close your eyes and drift deeper into sleep, imagine that somewhere, far beyond the reach of human knowledge, a white hole is waiting. Imagine a place where time itself spills backward, where the echoes of the past emerge into the present, where the boundaries between what was and what will be dissolve into a single eternal moment. Let that thought carry you into the darkness, into the quiet hum of the cosmos, into a place where the universe whispers its secrets in the stillness of the night. The Boltzmann brain paradox. Are you just a cosmic fluke? There is a haunting idea buried deep within the laws of physics, a thought so unsettling that it challenges the very foundation of our existence. It is the paradox of the Boltzmann brain, an idea that suggests you, your thoughts, your memories, your entire sense of self may not be what you believe. Instead, you might be nothing more than a fleeting accident, a momentary fluctuation in the endless void of the cosmos, a consciousness that came into being by sheer, improbable chance, and will vanish just as quickly. To understand this paradox, we must first step into the world of thermodynamics. The universe, as we know it, is bound by a fundamental rule. Entropy always increases. Everything moves from order to disorder, from structure to chaos. A hot cup of coffee left on a table cools down, never the other way around. A sandcastle on the beach is eventually eroded by the wind and waves, reduced to formless grains. The universe itself is no exception. It is slowly unraveling, expanding, cooling, drifting ever closer to a state of ultimate disorder, where all structure, all life, all meaning is eventually lost. But here is where things take a strange turn. If the universe is governed by randomness, by particles bouncing and colliding in an endless cosmic dance, then given enough time, even the most improbable events must eventually occur. If you stir cream into coffee, you expect it to mix and never spontaneously separate. And yet in theory, if you waited long enough, if you gave the universe an eternity, the particles might, by sheer chance, rearrange themselves back into perfect separation. Now take that idea and apply it to consciousness. Given infinite time, the random movements of particles might, by sheer accident, assemble a brain. Not just any brain, but a fully formed self-aware mind, complete with fabricated memories, an entire lifetime of experiences that never actually happened. In this scenario, your entire reality, all the people you know, the world you see, the past you remember, could be nothing more than an illusion, a temporary structure of atoms that will dissolve back into the void in an instant. It sounds impossible, absurd, and yet statistically, it might be far more likely than the reality you believe in. Think about it. Our universe is vast and complex, filled with galaxies, stars, and planets that have taken billions of years to form. Life as we know it has evolved through countless generations of struggle, randomness, and adaptation. But a Boltzmann brain, a fully formed mind appearing out of nowhere, would not require any of that. It would not need a planet, a civilization, a history. It would simply appear, momentarily aware, before dissolving back into nothingness. And given infinite time, the probability of such a mind forming by accident could actually be far greater than the probability of an entire ordered universe like ours existing. This is where the paradox lies. If Boltzmann brains are more statistically likely than real universes, how can we trust that we are not one of them? How do you know that you were not created just seconds ago, with a lifetime of false memories implanted by chance, destined to vanish in an instant? How do you know that the stars above you, the ground beneath your feet, even the very concept of time itself, are not simply figments of an illusion, an elaborate mirage conjured by randomness? It is a terrifying thought, one that fractures the very nature of reality itself. But it is also strangely poetic. If we are Boltzmann brains, then we are cosmic dreams, fleeting whispers of consciousness in the vast emptiness of the void. We are sparks that flicker for a moment before being swallowed by the eternal darkness, echoes of thoughts that will never be remembered, ideas that will never be spoken. But perhaps there is comfort in that. Perhaps, even if we are illusions, even if everything we know is a mere statistical accident, there is beauty in the fleeting nature of our existence. If this moment is all we have, then let it be enough. Let the stars burn bright, even if they are not real. Let the universe hum with silent wonder, even if it is just an echo. Let yourself drift into the embrace of sleep, knowing that for this moment, however brief, you are here, you are real, and that is all that matters. The black hole information paradox. Does the universe forget? Black holes are cosmic abysses, devourers of light and time, places where the laws of physics collapse into uncertainty. They lurk in the vastness of space, invisible to the eye, only revealing themselves through the violent dance of matter spiraling toward oblivion. But deep within their event horizons, a paradox emerges. one so unsettling that it challenges the very fabric of our reality. This is the black hole information paradox, a question that pits the laws of quantum mechanics against the principles of general relativity. It asks, when something falls into a black hole, does the universe forget it forever? To understand the problem, consider a book. A collection of knowledge, words imprinted on pages, each sentence a record of information. Now imagine throwing that book into a fire. The pages ignite, the words curl into smoke, the cover blackens and turns to ash. On the surface, it seems destroyed. But physics tells us otherwise. Every molecule, every atom that once formed the book still exists, merely transformed. In theory, if we had perfect knowledge of every particle, every wisp of smoke, we could reconstruct the book as it was. Information, according to the laws of physics, can never truly be lost. But black holes appear to defy this fundamental rule. When an object, be it a planet, a spaceship, or even a single photon, falls into a black hole, it crosses the event horizon, the boundary beyond which nothing can return. Whatever enters this forbidden zone is swallowed, absorbed into the singularity at the black hole's core. From the outside, it vanishes. No trace remains, not even information. It seems as though reality itself has deleted something, breaking the cosmic principle that information is eternal. This contradiction lay hidden for centuries, unnoticed because no one questioned whether black holes could shrink. But in 1974, Stephen Hawking made a groundbreaking discovery. Black holes are not completely black. They emit faint radiation due to quantum effects near the event horizon. Over vast stretches of time, this radiation slowly drains the black hole's mass, causing it to shrink, evaporate, and ultimately vanish. And here lies the paradox. If the black hole disappears, where does the information of everything it swallowed go? One possibility is that the information is simply gone. But if that were true, it would shatter the foundation of quantum mechanics. The universe has always obeyed the principle that information is never truly erased, only rearranged. If black holes destroy information, then the fundamental laws of physics break down. The universe would become unpredictable, chaotic, and fundamentally unknowable. Another possibility is that the information is somehow encoded in the Hawking radiation itself, hidden in a way we don't yet understand. Some physicists suggest that the radiation carries away the lost data in an incredibly subtle, scrambled form. If this is true, then black holes do not truly erase the past, but instead obscure it in a code we have yet to decipher. The information may still exist, but in a language beyond our comprehension. Then, there's the radical idea that the event horizon itself acts as a kind of holographic recording, storing the information of everything that falls in. This idea, known as the holographic principle, suggests that our universe itself might be a projection of deeper hidden physics, a cosmic illusion where information is stored on the very fabric of space-time. If true, then black holes do not truly destroy information, but rather scatter it across the universe in ways we have yet to grasp. But perhaps the most mind-bending possibility is that black holes don't erase information, they simply send it somewhere else, to another universe. Some theories propose that the interior of a black hole is not an ending, but a passage, a doorway through which information escapes, carried into another realm beyond our own. If so, then black holes might be the ultimate cosmic recyclers, not destroyers, but translators of reality into dimensions beyond our sight. The black hole information paradox is more than just a theoretical puzzle. It is a question that forces us to rethink the very nature of space, time, and existence itself. If we can solve it, we may finally understand what happens inside a black hole, whether information truly vanishes, whether reality is holographic, or whether our universe is part of something far greater, connected by the unseen threads of black holes that weave between worlds. And if black holes do erase information, then what does that mean for us? If a person, a life, a consciousness is ultimately just a pattern of information in the universe, then could we, too, one day be lost, swallowed by time, forgotten by existence itself? Or is there something deeper, some unknown force ensuring that nothing, no memory, no thought is ever truly erased? The great filter, the barrier that stops civilizations. The universe is ancient, vast beyond imagination, and filled with billions of stars and planets. If intelligent life is a natural outcome of cosmic evolution, then the galaxy should be brimming with civilizations, some older than ours by millions, even billions of years. And yet, when we look to the night sky, we see nothing. No grand structures orbiting distant stars, no cosmic highways stretching between planets, no signs that anyone, anywhere, has made their presence known. This eerie silence brings us to one of the most unsettling theories ever conceived: the Great Filter. The Great Filter is the idea that somewhere along the journey from lifeless matter to a galaxy-spanning civilization, there exists an almost insurmountable barrier, one that stops nearly all intelligent life from advancing beyond a certain point. It is the silent executioner that ensures the universe remains quiet. The question that haunts us is, have we already passed this filter, or is it still ahead of us? If the filter is behind us, then we are extraordinarily rare. Life itself may be the great hurdle, the emergence of self-replicating molecules, the leap from single-celled organisms to complex multicellular life, the ability to develop intelligence. Perhaps Earth is an anomaly, a cosmic lottery winner, in a universe where nearly every other planet remains barren and lifeless. If that's the case, then we have already overcome the hardest step. The silence of the cosmos simply means there were never many others to begin with. But what if the Great Filter is ahead of us? What if every civilization that reaches a certain level of advancement inevitably destroys itself? Perhaps it is in the nature of intelligent life to create the means of its own extinction. Nuclear war, environmental collapse, artificial intelligence, or some unforeseen catastrophe that wipes out every species before they ever become interstellar. If this is true, then humanity stands at a precipice, staring into the abyss of its own potential downfall. Consider the idea that every intelligent species might reach a stage where its technological progress accelerates beyond its ability to control it. A civilization that masters nuclear energy might inevitably turn it against itself. A species that creates artificial intelligence might be unable to stop it from spiraling beyond their command. A society that exploits its planet's resources might one day find itself unable to reverse the damage. In every scenario, progress sows the seeds of destruction. The further a civilization advances, the greater the risks become. And then there's a darker possibility, one that chills the mind like a whisper in an empty room. What if the reason we see no advanced civilizations is because, when they appear, they are removed? Imagine an unseen force lurking in the universe, waiting for intelligent life to reach a certain threshold before erasing it. A predator, an exterminator, an enforcer of cosmic silence. Perhaps the universe is not empty, but rather purged, again and again, ensuring that no species ever grows too powerful. The implications of this idea are terrifying. If the Great Filter is still ahead of us, it means our greatest dangers are yet to come. We may be advancing toward an invisible boundary, one that no civilization has ever crossed. Every technological breakthrough, every new frontier, could be one step closer to our own demise, and we might not even see it coming. But how do we know if the Great Filter is ahead or behind us? One clue may lie in the search for extraterrestrial life. If we discover simple life on Mars, Europa, or another nearby world, it would suggest that life is common. And if life is common, then the Great Filter must be beyond the stage of basic biology. That would mean the hardest steps are still to come, and that surviving the next centuries could be our greatest challenge. On the other hand, if we search the universe and find nothing, no fossils, no microscopic bacteria, no signs that life ever existed elsewhere, it would imply that the origin of life itself is the filter. It would mean that we have already passed the hardest step, and that intelligent civilizations are simply rare beyond comprehension. Yet, there is another chilling thought. What if we are simply not looking in the right way? What if other civilizations have already found ways to hide themselves, to remain unseen? What if we are the naive newcomers in a universe filled with silent watchers, waiting to see if we too will fall to the same fate as those before us? Some argue that this explains why no advanced species has colonized the galaxy. If the Great Filter is real, then civilizations never get far enough. They never build their empires among the stars. Instead, they collapse, vanish, or are removed before they ever leave their homeworlds. We may be on borrowed time. living in the brief moment before the inevitable, the vacuum decay paradox. Could the universe end without warning? The universe is vast, ancient, and seemingly eternal, stretching across the incomprehensible depths of time and space. It feels stable, like a grand cosmic structure that has existed for billions of years and will continue for billions more. But what if that sense of security is an illusion? What if right now we are living in a fragile, temporary version of reality, one that could vanish in an instant without a trace? This is the terrifying premise of the vacuum decay paradox, a theory that suggests our universe is not in its most stable form and could, at any moment, collapse into a more fundamental state of existence. This wouldn't be an explosion, an implosion, or even a violent event. It would be a silent rewriting of the very fabric of reality, erasing everything we know in a fraction of a second. No warning, no escape, just oblivion. To understand this haunting possibility, we must look at the Higgs field, an invisible energy field that permeates all of space and plays a crucial role in giving mass to fundamental particles. This field exists in a particular energy state, and most physicists believe it resides in what is called a metastable vacuum, a state that appears stable but may not be the lowest possible energy configuration. If this is true, then our universe is balanced precariously on a cosmic tightrope. It is stable for now, but not indefinitely. If a fluctuation or high-energy event were to trigger a transition, the Higgs field could suddenly collapse to a lower energy state, setting off a chain reaction that spreads across the cosmos at the speed of light. The result? A total reconfiguration of space, time, and the very laws of physics themselves. The most terrifying aspect of vacuum decay is its absolute finality. Unlike other cosmic disasters, such as asteroid impacts, gamma-ray bursts, or even the eventual heat death of the universe, vacuum decay doesn't just destroy things. It rewrites the rules of existence itself. Every atom, every particle, every force of nature that we currently understand would be obliterated in an instant. If this event were to occur somewhere in the universe, its effects would propagate outward at the speed of light, meaning we would never see it coming. One moment, we would be here, existing as we always have, and in the next, everything would be gone, erased from reality without a trace. But how likely is such an event? Theoretical physicists have spent years debating this question, and the answer is both reassuring and deeply unsettling. On one hand, if vacuum decay were an imminent threat, it might have already happened somewhere in the universe, and its deadly wave of destruction would already be on its way toward us. On the other hand, the vastness of the cosmos and the seemingly stable nature of the Higgs field suggest that even if vacuum decay is possible, it might not occur for trillions of years, far beyond the lifespan of our solar system, our galaxy, or even the universe as we currently understand it. However, there remains a lingering uncertainty. If a high-energy event, such as a collision between cosmic rays or an artificial experiment in a particle accelerator, were to disturb the Higgs field, could it trigger the end? The unsettling truth is that we don't know. One of the strangest implications of vacuum decay is that it would create a bubble of true vacuum, a region of space where the laws of physics have been rewritten. This bubble would expand outward at the speed of light, consuming everything in its path and replacing it with a new universe governed by entirely different principles. The forces that bind atoms together, the nature of time, and even the structure of reality itself could be utterly transformed. If another civilization existed on a distant planet, they too would experience the same instant erasure, never knowing what hit them. There would be no survivors, no remnants, no memories, only the unknowable void of a new cosmic order. Some scientists propose that vacuum decay, if it were to happen, wouldn't necessarily mean the end of existence, just the end of our existence. The universe wouldn't disappear entirely. Rather, it would be replaced by something else, something beyond our comprehension. If consciousness is bound to the specific physical laws of our current reality, then whatever comes next might be so alien that no sentient beings could ever emerge within it. In a way, this is even more disturbing than total annihilation. It suggests that all our achievements, all our history, and all our dreams might be nothing more than fleeting anomalies in a universe that was never truly stable. Yet, paradoxically, the idea of vacuum decay can also be oddly comforting. If the universe is going to be erased in an instant, without pain, without suffering, and without fear, then does it even matter? Unlike other existential threats which leave behind devastation and loss, vacuum decay would be completely indifferent. There would be no aftermath to worry about, no ruins, no echoes of destruction, just a seamless transition from something to nothing. It would be the ultimate reset button, pressing itself without warning and with no one left to mourn its effects. Of course, the alternative possibility is that our universe truly is stable, and vacuum decay will never occur. If that's the case, then we exist in a cosmic fortress, protected from such existential threats by the fundamental laws of physics. But if we are instead in a metastable state, then our entire reality is nothing more than a cosmic accident, an unstable structure waiting for the right moment to collapse. In this scenario, life itself is an improbable flicker in an impermanent universe, a fleeting dance of particles that will one day be erased, leaving behind nothing but an empty void. Philosophically, this raises profound questions about the nature of existence. If everything we know is temporary, does it change the meaning of our lives? Does it matter if the universe lasts for 1 billion years or 1 trillion, if in the end it all vanishes as if it never existed? Or is meaning something that we create, independent of the cosmic fate that awaits us? Perhaps the true beauty of life isn't found in its permanence, but in the fact that we exist at all, that for this brief moment we are here, thinking, feeling, and exploring the vast mysteries of the universe. As you drift into sleep, let your mind wander beyond the stars, beyond time, beyond the boundaries of existence itself. Let the vastness of the cosmos lull you into a deep, peaceful rest, knowing that for now you are here, and that is enough. The universe may be fragile, uncertain, and temporary, but in this moment it is real. And perhaps that is all that truly matters. The Planck star hypothesis. What happens inside a black hole? There is a place where time itself seems to collapse into nothingness, a region where gravity is so intense that even light cannot escape. This is the heart of a black hole, a cosmic abyss where the known laws of physics cease to function. But what if black holes aren't the eternal prisons we've imagined? What if, deep within their event horizons, something astonishing is taking place? The Planck star hypothesis challenges the traditional idea that black holes are one-way tickets to oblivion. Instead, it proposes that something truly mind-bending happens inside, a process so strange that it defies our normal understanding of time and space. A Planck star is a theoretical entity, first proposed by physicists Carlo Rovelli and Francesco Vidotto, that exists inside a black hole's singularity. In simple terms, it's a state of matter compressed to its absolute limit, where quantum effects prevent the black hole from collapsing into nothingness. Unlike the conventional idea of a singularity, an infinitely small and infinitely dense point, a Planck star suggests that black holes do not actually collapse into infinite density. Instead, at a microscopic scale, a counterforce emerges, halting the collapse and potentially allowing the black hole to bounce back over cosmic timescales. Imagine a rubber ball being compressed down to the tiniest possible point, and then, over an unimaginable span of time, it begins to expand again. But how could this happen when nothing is supposed to escape a black hole? This is where the nature of time dilation comes into play. When something falls into a black hole, an outside observer would see it slow down as it approaches the event horizon, almost as if time itself is freezing. From the perspective of someone outside the black hole, this process could take billions, even trillions of years. But from the perspective of the matter inside the black hole, things could be happening much faster. This paradox of time is one of the most mind-twisting aspects of black hole physics. Now consider this. If a black hole contains a Planck star at its core, then what we see as a black hole from the outside might not be permanent at all. Instead of a black hole lasting forever and gradually evaporating through Hawking radiation, the Planck star hypothesis suggests that black holes will eventually rebound, spitting their trapped matter and energy back into the universe in an incredibly slow process from our perspective, but one that might feel almost instantaneous from within. If true, this would mean that black holes are not the end of matter, but rather a cosmic recycling process. This idea raises another fascinating question. If black holes are eventually destined to explode outward, Could they be responsible for some of the mysterious high-energy cosmic events we observe in the universe? Some physicists speculate that the sudden eruption of a Planck star might explain certain unexplained bursts of gamma rays, immensely powerful explosions of radiation seen in distant galaxies. If so, it would mean that what we think of as the quiet death of a star might actually be setting the stage for an incredibly violent rebirth. But let's take this even further. If Planck stars do exist inside black holes, could they be connected to something even stranger? Some researchers have theorized that when a black hole collapses, its intense gravity might create a bridge, known as an Einstein-Rosen bridge or a wormhole, that links it to another part of the universe. Could it be that what we think of as a black hole in our universe is actually a white hole in another universe, spewing out energy and matter that had once been trapped inside? In this scenario, black holes wouldn't just be cosmic garbage disposals. They would be gateways to new regions of space-time. And what about the Big Bang itself? Could it be possible that the universe began as the rebirth of a collapsed black hole from a previous cosmic cycle? If so, then our universe may not be the first nor the last to exist. Instead of a singular event, the birth of the cosmos could be a repeating pattern in which universes emerge, collapse, and reform in an endless cycle. The Planck star hypothesis suggests that time, as we know it, might be far more fluid than we've ever imagined. But there's another unsettling aspect to this. If black holes eventually release their contents, does that mean information is never truly lost? This is one of the biggest mysteries in theoretical physics, the black hole information paradox. According to quantum mechanics, information about a system cannot be destroyed, but if a black hole swallows everything, where does that information go? If Planck stars exist and black holes eventually bounce back, then this paradox could be solved. The information isn't lost, it's merely trapped in a time-dilated limbo, waiting to be released over an incomprehensibly long period. Imagine, then, that in the far, far future, long after the last stars have burned out and the universe is cold and dark, the remnants of black holes begin to erupt, one by one, spewing out matter and energy that had been hidden for eons. The dead universe, long thought to be lifeless, would suddenly become active again. It's an almost poetic vision, the cosmos itself reviving from its own ashes, as if black holes were the seeds of new galaxies, waiting for the right moment to blossom. But if this is true, how could we ever prove it? Detecting a Planck star would be incredibly difficult because it would exist in a region that we cannot directly observe. However, scientists are already looking for clues. Tiny fluctuations in the radiation emitted from black holes, subtle shifts in the way space bends around them, or even sudden bursts of unexplained energy. Some have even speculated that future experiments in quantum gravity might one day allow us to glimpse the secret structure of space-time itself. Of course, this idea is still highly theoretical. We do not yet have proof that Planck stars exist, and many physicists remain skeptical. But the concept opens up a fascinating new way of thinking about the universe. If true, it would mean that black holes are not bottomless pits, but rather gateways to new cosmic transformations. Instead of being the grim reapers of the universe, they might be something far more mysterious, cosmic cocoons waiting to burst open and reshape reality. As you drift deeper into sleep, imagine that somewhere out there, in the depths of space, countless black holes are silently waiting for the moment, millions, perhaps billions of years from now, when they will awaken, releasing the secrets they've held for so long. Perhaps the universe itself is a story still unfolding, with each black hole marking a pause before the next grand chapter begins. Maybe, just maybe, we are part of an endless cycle of cosmic rebirth, where endings are merely the prelude to something greater. As we drift toward the edge of this journey, let your mind settle into the quiet vastness of thought. We have wandered through cosmic riddles, questioned the fabric of time, and brushed against the very limits of human understanding. And yet the universe remains, a silent, patient enigma, waiting for more questions, waiting for more dreams. The stars still shimmer in the endless dark, their light whispering across the ages, carrying secrets we may never fully grasp. The paradoxes we explored are not just puzzles, they are invitations to wonder, to imagine, to let curiosity stretch beyond the reach of certainty. In the grand design of existence, perhaps the greatest mystery is not out there, among the stars, but within, woven into our thoughts, our questions, our longing to understand. As you close your eyes, let the echoes of these ideas carry you into sleep. Let them swirl gently like distant galaxies, dissolving into the quiet rhythm of your breath. There is no rush for answers, no need for resolution, only the comforting thought that even in uncertainty, there is beauty. Rest easy, traveler of the mind. The universe will still be here when you wake.